Okay, cool. 540, single element in a sorted array. Given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Find a single element that appears only once. Um, oh, and it's sorted. Yeah, you can actually do better than that. You don't even need of like, oh, uh, could definitely do it of n time, but uh, I guess if it's sorted, then yeah, you could just do it in log, all of log, and um, hmm, how do I want to do it? So there are a lot of O of n solutions with like hash tables and such. And I would bring that up, uh, but we clearly want to be better than O of n because otherwise this is like an easy problem that we could do in 2 lines of code or so. Uh, okay, so I think this problem feels a little weird to me in the sense that like I don't know, it's just very like one off, right? So like I don't know how fun that is or whatever, but I guess it is okay. So I think the first observation I would know is that uh, 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 well, some of this is like half working backwards, but you don't even have to. The first thing you notice that well, if you want to do better than linear, uh, uh, the only way you could go about that is kind of take care of some structure in the data structure, and given that it's sorted, so that's already been done for you, and you could probably think of some kind of divide and conquer strategy, and kind of like, well, given a number, how do I figure out where to divide? And the other kind of observation I would say is that given a number and you know that it appears twice, then the number next to it is also the same number, right? But the next obvious question is then, well, is the number to the left yeah, it's the number to the left, uh, uh, the identical number, the number to the right, the identical number, right? And that kind of like allows you to kind of figure that out a little bit because then now that you have two duplicate numbers, are there um, odd number of numbers before those two numbers or after, right? And because if given n numbers and they're all paired up, if there's an odd number before that set, before the your period, if you will, then you know that is in that half, right? So I think that's all we're gonna need to do, and I'll start right now. So I mean that's a straightforward problem. Actually, maybe I retract a little bit, and maybe it's a little cute. I don't know how I feel about it, but I guess I feel that it's a little cute. Okay, but let's do two that size. I haven't done C++ in a while, but trying to mix this up a little bit. So instead of using C all the time, um, cool. Hmm. Yeah, I guess I could put this in here. So if you're new to the stream, I actually do this thing for binary search that I actually break it down to a for loop after accelerations, so that I just a little bit easier to kind of reason about the off by ones, which you'll see in a couple of minutes as I type this out. But okay. Okay, so that means it's a lot of kind of making sure you get. There's a lot of potential for off by ones, but so if the middle, so that means this means from H to mid is where the number is. Okay. Um, okay. If so, okay. Mm-hmm. Count is equal to mid minus H, and this is something I have to double check in a quick minute. Well, like in a few minutes, just because there's just so many potential by off by one, and when the core of the problem is to determine parity, the off by one actually hurts. So okay, so if this is odd, if this is odd number, that means it's on in the first half. Then you want the n to go to mid. Okay, so else it's equal to the n minus yeah, okay. Otherwise, then it's mid minus one. So okay, then the identical is okay. Yeah, maybe there's some duplication of code here, so maybe that's not great. But so something like that. And the determining thing is that whoops. Maybe that's just weird, but okay, let's take a quick look. This actually, I mean, this should not give us the wrong answer. Well, except for maybe some kind of crazy limit exceeded thing. Time limit exceeded. Because this should also actually just be 0, right? Right, let's bound check a little bit. Oh man, it ate my paren. Yeah, so this should be right only for the reason that because this never triggers, so it should always be right. Okay, cool. Now I could generate like a big case. That's a little tricky to generate, but okay. I mean, this is still kind of working, but I'm not super confident about it per se. Let's see what happens here. Okay, well, YOLO. Oh no. Oh well, I guess it could happen that it's the base case because I did something weird, but okay, that's good though. Mostly I was just lazy. I should have put in a different, bigger case, but one's in good time though. I think maybe it doesn't tell me. Okay, 8 milliseconds. It's just that it terminates a little bit early. Why is that? Okay, well let's find out. Let's find out, shall we? which I'm not. I would say I'm actually not super surprised about, if only because yeah, it's very easy to make an off by one error here. So uh, so yeah, I think I'm just a little scared about that in general. In this case, it keeps on going to the back, to all the way to the back. I think. Well, I don't know when I pasted, so no, that's not true. I guess it just goes to the middle, but it somehow isn't off by one in one of these halves. Okay. So mid and mid minus. How many numbers are between mid? Okay, so if the index is 5, does that mean that's 0, 1, 2, 3, 4? I mean, it seems like the logic is roughly right. Okay, I guess I just have to add more debugging things. Yes, I would. So it's 10,000 elements. Huh. That's interesting. I think I've messed up actually. I think we don't need to subtract it by h, because you actually don't need. It's not counting the number of elements from h to your pivot point. It's counting from the beginning all the way. So it's actually just yeah. Actually, so this is. It's just yeah. I know. Right. Yeah. Okay. Fine. Do it that way. Oops. Okay. Cool. Yeah. I think I just for some reason, well, actually, let me get it right before I kind of tell you why. Because okay, cool. Yeah. So this is a way. I mean, I actually like this problem a lot. But let me explain this problem for a second. So yeah, I'm impressed because I actually get. But yeah. So my mistake was I think so. So these two is just trying to figure out the period of like so mid is the period as in any binary search, and then the question is, well, if I'm next to my pair and my the other integer of the same value, and then the number of numbers before that, and not just from the beginning of your partition, but all of it, right? And because that number you could calculate in an instant time, which is actually just the index value of the period, you could figure it, and then you could kind of subdivide the chunks very quickly that way. I dig this problem a lot in general. I mean, I would say also that I'm a sucker for binary search problems on interviews because I think it's just something that's underutilized, and it comes up. I mean, I know that you can actually do it in library, but it still comes up a lot. And when you and when you're solving a problem, like the binary search isn't actually the hard, like the coding of the binary search isn't the tough part. The tough part is to kind of like knowing how to use or where to use the binary search. And for that reason, I actually like this a lot because it makes you, for me, it actually feels like something that is relatively novel in that, like given a period, what information do you know from that period? And it's something that I actually yeah, I mean, it feels to me very novel. Feel like I'm actually solving a problem versus feeling like I've done something before in a similar way. I could actually see myself going this problem. I think maybe it's a little bit on the tricky side, and it is definitely, to be honest, maybe I'm just a little biased and fanboying this a little bit. Because I think definitely, if I step back a little bit, there is a little bit tricky. There is a bit of a gotcha that we mentioned in the beginning with the kind of the odd even parity of the function. But I think like once you know that everything is clean. Yeah, okay. Maybe now that I'm saying it out loud, maybe it's a little tricky because actually the code is pretty straightforward, but it's just a binary search, and it becomes just like a binary search problem. But I think it's a very fun binary search problem, so I like it. But I think it's probably a little tricky, and you may have to give a lot of hints, and these are hints that as an interviewer, or as an interviewee, you take the hint, but you're not going to code anything, but you're not making any progress toward it. There's no like gradual, getting to that gradual solution. Is more like, okay, well, it's very binary, and they're like, oh, okay, I don't know it, I don't know it. Okay, now I know it, and I get to solve it. Right. So maybe to that end, it's a little bit of a tricky problem, but for and maybe I mean maybe I have to admit that I was wrong a couple of minutes ago. So maybe it's not a great interview problem to that extent, but I think it's a very fun, challenging programming problem in terms of algorithms, and I dig it.